That's where the fun begins. So it's dy dx equals 1 plus y over x. All right, so what I want to do is separate my variables so that the x's are on the same side of the equation and the y's are on the same side of the equation. All right?
How do we get to 1 plus y over x?
Oh, sorry.
Oh, got it.
Good.
Okay, I'm like, what am I?
So what we're going to do is just move some things around. I'll just swap these diagonals. So it would be dy over 1 plus y equals dx over x. Yep, diagonals in a proportion are interchangeable. It's cross multiplication is the implication. Right. So we can clean this up further. I'm going to make it look a little bit more antiderivative-y. So 1 over 1 plus y dy would be equal to 1 over x dx. Right, so it's a cleaner form because the next step in the process is to take the antiderivative of both sides. Right. So what would be the antiderivative of 1 over 1 plus y? 1 plus y, exactly. You can go absolute brackets or parentheses. It really doesn't make a difference for what we need to do because we're going to settle in on a particular solution. But technically, whenever you find an antiderivative, it's the natural log of the absolute value. And I'll show you why it doesn't matter in a few minutes.
Is the antiderivative dy 0?
Say it again?
Is the antiderivative dy 0?
No.
Where did dy go?
That's more of an instruction telling you to take the antiderivative of the thing that precedes it. So antiderivative of 1 over x? ln of x plus c.
So only when there's dx you have the constant.
Only when, well, really, I mean, there's a plus c on both sides of the equation. It's just we consolidate it to the right hand side. Right. So I'm going to write this instead of ln. I'm going to write it as the log base e of 1 plus y is equal to ln of x plus c.
Wait, what do you mean there's a c on both sides? Why aren't you writing on the left side?
I'll show you.
That's a constant.
All right, so I'm going to apply a little Lagrange action and write this as 1 plus y equals e to the ln x plus c. Talked about this last time. We have a sum in an exponent. We could break that up. Into the product of two monomials. Right, so this is basically keep the base, add the exponents, put it in reverse. Right, so we're undoing it. Right. E to the c is the same as what?
C.
C. Because it's a constant to a constant. So c e to the ln of the absolute value of x. All right, just again, still housekeeping, we're trying to get y equals. So the good news is, and this seems weird, like maybe not something that we would be able to do, but we can actually sorry, I'm getting like calendar alerts, like 30 of them all in one shot for some reason. So anyway, I can drop the natural log, and I'll explain why in a sec. The only reason I'm able to drop the natural log is because of the presence of the C. And I'll show you what that looks like in a sec. I'll do it on the sideboard.
Wait, drop
The natural log on the left-hand side.
got it.
All right, now, what is e to the ln of the natural log of x going to be?
X.
So that'll be the natural log of x. Right? We're going to drop that natural log in a second. And again, I'll explain why. It seems magical now, but there's a perfectly legitimate explanation, all having to do with that constant c. And we get our general solution of y equals cx minus 1. All right. They gave us a condition. They tell us that f of negative 1 is equal to 1. All right, so they're telling us an x value and a y value. So 1 equals c times negative 1 minus 1.
C equals.
C equals negative 2. All right. So this is where, you can get wires crossed a little bit, I guess. This little step right here, c times negative 1. See how it remains as a negative c? Previously, the c would absorb all other constants. So if I multiply c by negative 1, when I was in the process of anti-differentiating, then this ought to become a positive c. The issue is we're now treating this c as a variable, all right? So it wouldn't absorb anymore. So in the process of fleshing out what the value of c is, we would have to treat it as a variable. All right, it's a source of misconceptions. So treat as a variable. All right, because it's not in the context of taking the antiderivative, so it's not an absorbing constant anymore. All right, we're actually trying to flesh out what that value would be. So, if you kind of flesh it out, I mean, you just do a quick check. I plug in a negative 1 here. If I plug in a negative 1, I get a 2 minus 1, which is 1, so it checks out. If I allowed the c to absorb the negative 1, I would get a 2. Negative 2 times 2 would be equal to negative 4 minus 1 would be negative 5. Okay, so in this context, the c would no longer absorb other constants. It's only in the context of the anti-differentiation that it does. All right. So as you go forward, when you do the practice problems, this is probably the best I can get. When you do the practice problems, if you're finding that you're getting your antiderivatives correct, so the differential equation solution that involves the plus c, that's all fine, but you're getting your particular solution incorrect, right? So you're off by a constant here or there, it's probably because of a misconception related to the c. All right, so if that happens, talk to me and I'll help you flesh it out. All right, so hopefully that makes sense. If not, we'll have to figure something out. Anyway, you're working through page 11, obviously not all today because there's a ton of problems. That's pretty much going to get you through roughly the next week, because tomorrow we got the money workshop and an opportunity to score some points because you'll have a reflection for that. If you didn't do the reflection last time, sorry, you're out of luck. You won't get those points. If you were absent, then you were never entitled to those points anyway. But if you were here and you didn't do it, you get a 0, so that stinks. But the next one is tomorrow if you do the reflection, you'll get a couple points for that. So definitely take advantage of that.
Is the same lady coming in?
Say it again?
Same lady?
Same lady, yeah. And then you're off Friday, Monday, and Tuesday, right?
And the Saturday,
Yeah.
Sunday.
So then, well, thank you for that. Thank you, that was so useful. Yes, of course you're off Saturday and Sunday also. Everybody contributes.
Oh, hey, Wednesday?
Anyway, also next week, you're gonna have an additional money workshop. So that's gonna bag another day. So out of the 2 days that you're here, three days that you're here,
3 days that we're here, 1 day that we're workshop.
one day you have a workshop, so there'll be 2 class days. So you'll have, well, whatever I give you, I mean, what are we down to, like 4 minutes? A little bit more than
It's like
that.
9.
Yeah, 9-ish, enough to get a problem or 2 done, but then you'll have 2 more class sessions, and then we'll go from there. So I had intended to give you that exit ticket on anti-derivatives, but 2-hour delay, I wasn't gonna push it, so we'll do that sometime next week. Okay?
Thank you.
No problem. Thank you for saying thank you.